Welcome to RCC's Math Tape 085, Equations of Lines. Up to this point, you have been given the equation of the line, and from that information you've obtained the slope of the line, its y-intercept, some points on the line, and the graph of the line. Now we go somewhat in reverse. We'll give you enough information to let you figure out the equation of the line. As you work through this material, be sure to take notes. Make sure they're accurate and thorough and complete. Mark on your notes any places you don't understand so that you can ask for help when you go to the lab. Also, on the exercises I give you, be sure to mark any places you have trouble so that you can ask for help from the lab instructors or the tutors when you're in the lab. Now let's begin. On this tape we have two objectives. Objective 1 is to find the equation of a line given a point and the slope. Find the equation of a line given a point and the slope. Objective 2 is find the equation of a line given 2 points. Given 2 points. Notice the similarity between these two. Objective 1 will give you a point and the slope. That's two pieces of information. One piece of information is a point, the other is the slope. In Objective 2, we'll find the equation of a line given 2 points. Once again, two pieces of information. This time, both of them are points. To accomplish these two objectives, we need a formula that we have not seen before together. So our first task is to derive the needed formula. First we will derive this needed formula. Now you understand that deriving a formula means we take information that we already know and manipulate that information to come up with the formula that's required. So let's recall a bit of information that is very familiar to you. Recall that the formula m equals y2 subtract y1 over x2 subtract x1. This formula is the slope of the line through point number 1, x1, y1, and point number 2, x2, y2. Our slope formula is the slope of the line through 2 points, point number 1 and point number 2. So what we want to do is we want to use this formula, this information, to derive a slightly different formula. Notice that in the formula there are really three things. M, the slope, which you're going to come up with from this formula typically, and then point number 1, x1, y1, which fits into the formula in its designated spot, and point number 2, x2, y2, which fits into the formula in its designated spot. So let's see how we can begin with certain pieces of this and come up with our needed formula. Let's assume that we are given m, the slope, and x1, y1, which is 1 point. Remember that in Objective 1, we are supposed to use a point and the slope to come up with the equation. So given m, the slope, and x1, y1, a point, use the generic point xy, the generic point xy, for the second point. Why? Because we don't know the second point. We can't assign it a specific value because we don't know which point it is. So we'll use the generic. So what I'll do is, in the slope formula, remember our format, the slope formula, m, which is the m we're given, and we'll fill in y2, which is the second y, which we're calling the generic y, minus y1, which is y1, over the second x, which is x, minus the first x, which is x1. So we have m equals y subtract y1 over x subtract x1. Let me write it again here, show it again here, without all the parentheses. Now, here's a formula. It involves the slope, m, which we can fill in with a number if we're given that, the point 1, x1, y1, filled into its needed place, and the generic xy to cover the second point. This formula would do the job, but it's not very easy to work with, and so let's apply our algebra knowledge and first clear the fraction. Remember how to clear the fraction? We multiply both sides of the equation by the least common denominator of all the fractions in the problem. There's only one fraction in the problem, so we'll multiply both sides by the single denominator, x minus x1. So let's do just that. Multiply both sides of the equation by x minus x1. This gives us m times x minus x1 equals the big fraction y minus y1 over x minus x1 times x minus x1. On the right-hand side, the x minus x1 cancels. And so we're left with m times x minus x1 is equal to y minus y1. This is a much better form. It still, however, is not written quite the way the formula is typically given. We typically have the y expression on the left and the m times the x expression on the right. That is, we simply swap sides for the two parts of the equation. When we swap sides, we get what is called the point-slope formula for a line. Here it is. Point-slope formula for a line. It is y minus y1 is equal to m times x minus x1. I've put a star beside this to point out how important it is, and you must memorize this formula. You will be expected to know this formula, which we will use for finding the equation of a line, given the requisite information. Y minus y1 is equal to m times x minus x1. Now that we have derived the formula, and you know that you must memorize it, let's look at some examples of putting this formula to use. Remember that when we have a formula that we must memorize, it is smart to write the formula down just before we use it each time it's needed for a problem. So that's what we'll do as we go through our examples.